Alright, let's look at the practice exam 3, problem number 9. Alright, part A, we want to find dy over dx by implicit differentiation. Alright, so let's do that. So since we're looking for dy over dx, so it makes sense to take the derivative with respect to x. Alright, so let's take the derivative of the left hand side. Alright, derivative of tangent is secant squared. So we have secant squared. Right, we're going to leave the inside function as it is. So I'm going to just do that. Right, but we still have to multiply by derivative inside, which is 2 plus derivative of y is dy over dx. Right, is equal to derivative of 6x is just 6. Right, then what we're looking for is dy over dx. Right, so I'm going to first get rid of secant squared. Right, so secant squared is the reciprocal of cosine squared. So why don't I just multiply by cosine squared of 2x plus 2x plus y. Right, so since if you multiply secant squared by cosine squared, they're reciprocal of each other, so you're going to get 1. So what you're left with, 2 plus dy over dx, right? Then we still have to multiply the right hand side, which is 6, by cosine squared of 2x plus y. Alright, then one more thing, we just need to get rid of this 2. We can simply subtract 2. So dy over dx, which is what we're looking for, would be 6 cosine of squared of 2x plus y minus 2. Right? So this is dy over dx that we were looking for. Right? Let's look at part B. We want to find the equation of the tangent line to the curve at 0, 0. Right? So the point is already given, so I'm going to call this guy x1, y1. Right? 0, 0, and we just need to find the slope. So slope m is going to be just find the derivative, which we already did in part A, then plug in x equals 0 and y equals 0, because that's the point we're given. Right? So let's plug it in. So you have a 6 cosine squared of 2 times 0 plus 0 is 0. Cosine of 0 minus 2. Right? Cosine of 0 is 1, square that is 1, so 6 minus 2 is 4. Right? Then we know that here x-intercept and also y-intercept is equal to 0 since it goes through the origin. So this tells you that y-intercept b is equal to 0. Right? So for this one, I'm going to use the slope-intercept form, which is y equals mx plus b. Right? So therefore, y is equal to m is 4, x, b is 0. So I'm not going to write that down. So that's the equation of the tangent line we were looking for. Alright, that's it. I hope that this was clear.